Welcome to Physics 2 Lab 3 circuits. Let's get into it. So the table of contents, you don't need to see that. Okay, so the goals for this lab were to understand current and voltage with resistors and capacitors. We used a model, not a computational model, but like a simulation to measure the electric current and potential difference with simulated ammeters. We also found the time constant that was using experimental values and the computed values. So the key concepts that were used in this lab were essentially the idea of voltage is the most important one. The voltage is equal to the current times the resistance. And we also have this other equation that relates voltage to current and resistance as well as time, which we will be using to calculate the time constant. So yeah, we also use the concepts to calculate resistance, Kirchhoff, and current also. Kirchhoff's voltage law and Kirchhoff's current law, which are better known as the loop rules and the node rules. Basically, that details that like the current going into a node. The node rule is the current going into a node is equal to the current coming out of the node, and then the loop rule is that the current in the loop is always the same within like a closed loop. So okay, part one of the experiment. This is the setup. We have two batteries, we have two ammeters, and we have two resistors. They're connected in series, and the experimental value of the current in the experimental value of the current in the circuit was the point of interest that we were measuring, and we calculated it to be 2 amperes, and that's what we measured it to be as well. And so our model is a good prediction. Yeah. So here we can also see a graph of the voltage over the different components of the circuit. So yeah, and with that graph, you can see we have a calculation for every component in the circuit. What is the change in the voltage? And if the line is flat, there will be 0 change in voltage. And that's expected because the ammeters are they're programmed not to have any sort of resistance, as well as the wires and everything like that. So we expect the resistance in like a 47 ohm resistor to be 47 ohms, and we measured it to be 48. And then in the 100 ohm resistor, it was 102. And so they're pretty good. There's a little bit of error, likely due to just imprecisions in the ammeter. Perhaps they're coded into the ammeters so that they can simulate real-world situations more closely. But yeah, so in experiment 2, it was a similar setup, except there's only one battery and no resistors. Instead of resistors, they had a capacitor and a light bulb. So it's a 9-volt battery, a 10-ohm light bulb, and a 0.2 farads capacitor. And then we repeated the experiment with a 20-ohm light bulb to see what the difference would be. And the thing we're measuring is the time it takes to discharge and recharge the capacitor. So to charge the capacitor, it took 16 seconds, and to discharge the capacitor, it took 15 seconds, which we can say that that's within the error range, and they're pretty much the same. The time it took to discharge the capacitor and charge it with a 20-ohm light bulb instead of the 10-ohm one was also almost the same, and so that makes sense that the whether it's discharging or charging doesn't affect the time. However, the resistance of the light bulb does, and it double the resistance, double the time it took to charge the capacitor. We also calculated the time constant by multiplying the resistance times the capacitance, and that was given to be 6 seconds for that capacitor. And when we experimentally measured that time constant, it was 5.8 seconds, so that's pretty close to our predicted value. So what if you were doing this experiment in real life and use an actual ammeter? Well, real ammeters have resistance, so there would be non-zero resistance when you do that. And also, real ammeters, because they have resistance, they would have a voltage drop over that, and so they would cause lower current in the circuit than if they weren't used. So if this experiment were being done in real life, and a real battery was used to charge the capacitor, resistor in the circuit, then it would be a little bit slower, like very marginally slower, because there is resistance associated with wires. in real life, not so in the simulation. But that difference is orders of magnitude smaller than would be detectable by a human. So it doesn't really affect the numbers that much.